How to complete IV dosage calculations. Okay, first thing I want to tell you is if you do not have any issues with figuring these problems and my formula confuses you, do what works for you. This formula, I will tell you though, if you can put the right numbers in the right places and do the calculations correctly, you will be guaranteed to come up with the right answer. So let's look at this. You're going to see I have some different geometric figures here. I have two of each, meaning that in these geometric figures, the value of what it is what number you have or what you're looking for is going to be the same in those geometric figures. If it's a different geometric figure, it's a different value. So the very first thing we need to do in that first blank is figure out what it is we're looking for. Are we looking for how many tablets to give, how many mLs to give, how many drips per minute to give, etc. That value, the tabs, the capsules, the mLs, the drips, is going to be put in that first green square, meaning that that same value has to go in the second green square. So in the second blank, what information do we already have from the word problem that matches what it is we're looking for? And then we fill in those blanks. The third blank, this is going to be what our prescription is, what the healthcare provider has ordered. So before we see how this works, there's a couple other things we need to look at first. So important information, we need to know what that administration set is. We're going to find out by looking at our tubing package. And if you want an example other than what's in this picture, pull out the tubing that is in your black bag and look at the package. You'll see a blue drop or a blue square and it has a number in it. That number will either be 10, 15, 20, or 60. This is telling us what the internal diameter of the internal lumen is. And it will indicate how many drops using that tubing will equal 1 ml. GTT is our approved abbreviation for drop. We also need to look at those rounding rules because you're either going to be rounding to the nearest tenth or to a whole number in IV dosage calculation. With drips per minute, this will always be a whole number. The only other time we're going to always have a whole number is if it's capsules, because we cannot have a partial capsule, we cannot have a partial drop. They're going to be whole one way or the other. So then we look at drips per minute, or I'm sorry, mLs per hour. That will always be rounded to the nearest tenth. So if it is a number that is 5 to 9, we will always round up. If it is a number that is 1 to 4, we are always going to keep it the same. So it will always stay the same. Let's look at a couple of examples. We have 25.735. If we want to round it to the nearest tenth, the 5 will round the 3 up to a 4, but 4 stays the same. So that means we would have 25.7. If we're rounding it to the nearest whole number, the 7 rounds the 5 up to a 6, so we have 26. A second example, we have 25.35. The 5 is going to round the 3 up to a 4, which stays the same. So that means if we're going to the nearest tenth, that would be 25.4. If we're rounding it to the nearest whole number, then the 4 does not change. It stays the same, meaning our answer would be 25. Figuring mLs per hour. This is probably the easiest part of IV dosage calculation. We are going to divide the amount of the solution by the time that it's to be infused in hours. So we're going to infuse 500 mLs over 6 hours. Very simply, we divide 500 mLs by 6 hours. That's going to give us a figure of 83.33 to infinity, or 83.3. Remember, mLs is always going to be rounded to the nearest tenth. So let's see how this formula works. We're going to figure drips per minute if it's to be infused over an hour. Our order is to infuse 500 mLs over 2 hours, and what we have available, we have a 20 drip per ml administration set. So first of all, what are we looking for? We're looking for drips per minute. So that value that goes in that first green square is going to be drips. What do we know for the second blank in the information that we're given? We know that we have a 20 drip per 1 ml administration set. Drips has to go in that green square, so we know that the 20 drips goes on top and the 1 ml will go on bottom. So now the value that's in that orange circle is mLs. What is our order? That's going to be our third blank. We know that we are supposed to administer 500 mLs over 2 hours, meaning we know mLs goes in that orange circle, so mLs has to go in the other orange circle. So it's guiding you as to how to set up your problem. We have 500 mLs over 2 hours. So now we know that that purple value is going to be hours. Excuse me. So that means in our next purple diamond, that value is hours. So we know there is 1 hour and 60 minutes. We're looking for drips per minute, not drips per hour. So we have to convert hours to minutes. We're going to multiply across the top. We're going to multiply across the bottom, and then we'll divide those two figures. So 20 times 500 times 1 gives us 10,000. 1 times 2 times 60 gives us 120. We divide 10,000 by 120, and that is 83.33. So 83 drips per minute, because it has to be a whole number. Well, what if we have less than an hour to infuse this volume? We have been ordered to administer 250 mLs over 30 minutes using a 15 drip per ml administration set. So what are we looking for? We're looking for drips per minute. So drips goes in our green square. What do we know regarding that information? We know we have a 15 drip per ml set. So 15 drips over 1 ml. What is our order? It's 250 mLs to be administered over 30 minutes. Well, we're looking for drips per minute, so we don't have to convert the minutes to minutes because we already have minutes. We multiply 15 by 250, that gives us 3750. We multiply 1 times 30, which gives us 30. We divide 3750 by 30, and that gives us 125 drips per minute. But what if too much is infused or not enough is infused? Then we have to recalculate. We have, for example, 500 mLs was to infuse over 4 hours, but after 1 hour, 300 mLs has infused, which is way too fast. So we are using a 20 drip per ml administration set. We need to recalculate our drips per minute rate. First of all, we need to figure out how many mLs are left. We were supposed to give 500. After 1 hour, 300 has infused. So how much do we have left? 200. We need to determine how much time is left. So we were supposed to do this over 4 hours. We're at the 1 hour mark, so 4 minus 1 is 3 hours. So now we look at those highlighted numbers. Those are the figures that we're going to use to recalculate our drip per minute rate. So we're looking for drips. We know we have the 20 drip per 1 ml set. We need to give 200 mLs over 3 hours. Well, we're looking for drips per minute, so we have to convert the hours to minutes. Now we do 1 hour over 60 minutes. Multiply across, we have 20 times 200 times 1 gives us 4,000. We multiply across on the bottom. 1 times 3 times 60 gives us 180. 4,000 divided by 180 is 16.6. We need to give a whole number, so we do our appropriate rounding, and that's 17 drips per minute. Now we need to try and figure out when the infusion will be complete. So 500 mLs was started at 2110. Remember, we always use military time. And it was infusing at 125 mLs per hour. So what time is that infusion going to be completed? We start off by dividing the solution amount by the rate that it's going at. So 500 divided by 125 mLs per hour, or if we had 4 hours, that's what would go on the bottom. So we divide 500 by 125, and that gives us 4 hours. We started at 2100 or 2110, so 9:10 p.m. We need to add 4 hours to that. Well, we add 4 hours, that gives us 2510, but we know in military time there's no such thing as 2500 hours. We only go as far as 2400. So if we subtract 24 from 2510, that gives us 0110. And that is the military time this infusion will be completed at, 1:10 a.m. So let's do it again. 500 mLs was initiated at 16:04, so 4:04 p.m. What time will it be completed? Again, we divide the solution amount by the infusion rate. 500 divided by 75, that gives us 6.67 hours. Now remember, this is hours. This is not 6 hours, 67 minutes. This is 6.67 hours. So we have to convert that 0.67 to minutes. And we do that very simply by taking 0.67 times 60. That gives us 40.2. We round it to 40. So 6 hours, 40 minutes. We're going to add 6 hours, 40 minutes to 16:04. That gives us 22:44. That's the time it will be finished. Good luck. Let me know if you have problems.